This video was made possible by StruSoft. Next, we shall talk about Shell Orthotropy. Orthotropy is a type of anisotropy in which the material properties differ in three different main directions. For example, timber can be considered orthotrophic material, and steel would be an example of an isotrophic material. In FEM-design and grasshopper context, we can use the Shell Orthotropy construct component to define the ratio of elastic modulus between x and y directions on a shell element's local coordinate system. Let's see this in practice. Connect the Shell Orthotropy output to the plate component's Shell Orthotropy input. In Rhino, I have modeled a square plate. The local coordinate system of the shell is also visible. The orthotropy component has two inputs, the alpha value and the ratio value. Alpha value tells us the E1 direction in relation to the shell element's local x-axis. If the value is set to 0, the E1 direction is parallel to the x-axis. If I change the alpha value, you can see the direction rotating. When it's set to 90 degrees, the directions are practically flipped. Let's reset the value. The ortho ratio tells us the value of E2 divided by E1. That if the ratio is 0.1, E2 is only 10% of E1. In practice, this means that almost all of the load is transmitted in the E1 direction. If the value is set to 1, E2 and E1 are equal. This means that the load is transmitted equally in both directions. Let's see this in FEM-design. In the model, I have rigid supports and hinged edge connections. I will run the analysis and navigate to results. The ratio is set to 1 and it can be verified that all of the edges collect the load equally. I will now change the ratio to 0.1. We run the analysis, navigate to reactions. It can now be observed that these edges have collected a larger amount of support reactions than these edges. This is because the E2, which is in this direction, has only 10% of the stiffness of the E1, which is in this direction. Here are the directions displayed in Rhino. The forces are distributed in relation to stiffness. If I change the alpha value to 90 degrees, we run the analysis, navigate to results. It can now be observed that the orthotropic direction has rotated 90 degrees.